Second installment, we're going to talk a little bit about quantitative data and the things that we need to look at when we're looking at quantitative data. Of course, we begin with the concept of a dot plot and then describe shapes of dot plots as roughly symmetric, skewed right, or skewed left. So roughly symmetric means the left and right side look the same or roughly the same. Skewed right means the data is longer or the tail is going to be on the left. And skewed left means the tail is going to be longer on the right. When we begin describing quantitative data, really any data actually, we want to think about the center, anything unusual, the shape, the spread, and we want to make sure we're really specific to the prompt or to the problem we're looking at. Okay, so when we think about the center, we can think about it as two things, mean or median. And then depending on which one we're picking, whether it's mean or median, then spread might be different, right? So after we say, okay, we're going to use the median, then we still want to talk about if there's an outlier. We still want to talk about what the shape is, but when we talk about spread, we want to talk about the IQR, right? But if we want to talk about the mean of the data, we're going to talk about the outliers, we're going to talk about the shape, but we're now going to talk about standard deviation. To talk about an outlier, you have to know something about Q1, Q2, Q3 in the box and whisker plot. And so the formula to determine if a value is too big for the data set is to take Q3, which is that third median, and add 1.5 times the IQR, which I didn't write that on here and I should have. Let me just kind of add it really quick. But you can determine the IQR simply by doing or finding Q3 and subtracting Q1, right? That's going to give you your IQR. And don't forget, you can find these Q1s, Q3s by putting the numbers in order from smallest to biggest. The median in the center of the data is, of course, the median. The median of the first half of the data is Q1, and the median of the second half of the data is Q3, right? And a really quick reminder of skewed left, symmetric, and skewed right when you're looking at a box and whisker plot. But custom BS, this is what we do every time we want to describe some data that's given to us so that the reader understands what's going on. Okay, hold on. Okay, so one of the things that we need to be able to do is take quantitative data and discuss the spread of the data. So there's three ways that we've talked about to do this so far. Range, which we can always use, but it's not very descriptive of the data. Median, IQR, which we use when we're discussing medians, and standard deviation, which we discuss when we're doing mean. So remember, standard deviation is the tricky one to find. You take every data value, subtract the mean, square it, divide it by the number of terms in the data set minus 1, and then take the square root of it, okay? So remember, if I take the square root off, that's called variance. I take the square root of that's called standard deviation, okay? Few things that we need to know about standard deviation. It's always positive. It says it's always greater than 0, but actually can be 0, right? So it's always positive or 0. When it is 0, that means there's absolutely no variability in the data. So like every number in the data set is exactly the same. Your standard deviation is 0 because there's no deviation from the mean. The larger the value of standard deviation, the greater the variance. So like even if I have small numbers, 12, 63, 125, 500, there's quite a bit of variability in the numbers. So my standard deviation would be larger in this data set than 893, 894, 895 because these are all kind of similar numbers really close to each other, even though they're big numbers. Standard deviation is not resistant. Remember we talked about the fact that standard deviation is greatly affected by outliers. So if we have major outliers in the data, we don't really want to use standard deviation, or we have to remove the outlier and then also say we removed an outlier. So that's a conversation for later. And then only use mean when, or only use standard deviation when mean is chosen as center. So don't talk about median and then go into talking about standard deviation, right? Because standard deviation formula involves mean. So that means we only want to use it when we're discussing mean. And then IQR. IQR is kind of measuring the same thing, still measuring variability of the data, but now we're only measuring the variability or the range of the middle half of the data. We use this when we might have extreme outliers because it is resistant to outliers. And we want to make sure that we only use median. Oh wow, I did it again. We only use IQR when we choose median as the center of the data. Okay? It would be a good time to pause and try a free response AP question. So hit pause and see what you can do on this question. Okay, so what you have there is a two-way table, and you're wanting to kind of figure some stuff out about the data. So you're going to have to make some charts and kind of draw some conclusions. So the first part of the data is talking about males and females and whether or not they own or rent. And so part A, here's the chart, and then part A asks what percent of males own, right? So we put the percent or the number of males in the bottom, and we put how many of them own in the top, and we end up with 72.5%. Then part B says make a graph to compare the distribution. You might do this, right? But it's really not as helpful as you want it to be, except to say, okay, well, overall, more males and females own their houses rather than rent. But actually, what you want to make is something like this, where you can actually compare the percentages. Because when you start looking at percentages of males versus females, where you can actually compare gender, you can see it's like 72.5% of males own versus rent, and 73.5% of females own versus rent. And so it turns out that there appears to be little difference in gender about whether or not you are renting or owning. Okay? And then the second part says, new two-way table, this time married, not married, own rent. And it says, what does it say? I'm looking for it, sorry. For the members of the sample, is the relationship between marital status and housing status stronger or weaker than the relationship between gender and then owning houses or renting houses? So now when you do your same kind of graph, 81% of married owns, 19% rents, and then 60% not married owns versus 40% rents. And so you can see the relationship is stronger because there's an obvious difference between married, not married, whereas for males, females, there was not an obvious difference. Okay?